Hey, hello students. I'm making this video. This is the last module and module number 11. And this is about on sequences and series. So I'll try to catch up with 13.1, which does deal with the sequence, then the nth term, then also how to write uh, how to find the terms of the sequence, and we will see the geometric sequence maybe or arithmetic sequence, and then also may not be a geometric sequence and arithmetic sequence also. So at each stage we will see, and how we will see how to use the graphing calculator to figure this out. So the first problem is, look at the very first example. Find the first four terms and the 100th term of the sequence whose nth term is given. So first of all, what is the meaning of nth term, right? So just in case you forget the nth term, I'll just give an example so that we really understand what is nth. If I have 5 and I put 9, and you can clearly see this sequence every time there is a number which goes on adding up. So if I say this is like a n and this is like a an, is the first place number, and then position number. So one, two, three, fourth position. And you can see the very first term, and usually we write it like A1, then A2, this is the second number, that's the third position number, this is the fourth position number. And likewise, we can say AN, this could be nth position, we call it as AN. So that's what that AN means. So if you see the sequence here, each time what you're doing is you're adding plus 4. So 5 plus 4, so this is 5 plus 4. And then again you add plus 4, that means A3 is whatever the 9 is the previous is, or you can say that A3 is the 5 was the beginning, and then you added 2 times, you added 5 2 times. So you added 4 2 times, 2 times. So and then this is A3. So this A1 is 5, and you added 4 ones. Likewise, we can think of this A4 is you're adding one more time, another 4. So this goes plus 4. So that means you're adding 3 fours from the beginning. That means it was 5 was the first term, 5 was the first. And then you're adding 3 times 4. That means you're adding 4. You are doing it 3 times. I'm a little uncomfortable. I'm at the New York airport and I'm still where I have a transit 2 hours flight to go. And I thought of making this video at one of the corners. You can see here. Okay. So in other words, so if the position now what this means is, if the position number is 2, then you're adding 4 1 times. If the position number is 3, that means 3, it is 2 times. See? If it is position number is 4, and you are adding this, it's always 1 less, and that's why this is the nth term formula type. It means A of n is always the very first one plus d times, that means whatever the difference, that's called a 4. The 4 that you see here is the common difference. So there's always difference is always the same for, and you're multiplying n minus 1. So this is how the nth term formula uh, is to be. If they ask you to create a n term formula, that's how you do. But right now they already gave us here the n term formula. Okay, so what this basically means, let's see here. An. So you're given the n, and all you do is a of 1. That's the first one. Put 4n minus 2. A of 2, you put equals 4 times. So n is 1, so put a 1 minus 2, and you get 4 minus 2 equals 6, 2. And the same thing, second one. And likewise, you figure out this. If the question is a of 100, all you do is 100. And the 100th term is 4 times 100 minus 2. That will be 400 minus 2 will be 398, and you're done. So that's all the first question is. Let's go to the second. So the second question is same thing, but this time, see, this is neither arithmetic or not geometric sequence. It's just kind of numbers. Uh, so all you do is put one. Let's say you want to figure out one. Not getting proper. I can't contract. Okay, let me see. So it is fraction. It's going to be 8 times 1 and then 3 times 1 square minus 2 equals 8 over 3. So 3, this will be just a 1, I think. And you can see it is just an 8. But if you want to do this one, 2, so it will be 8 times 2. So 8 times, and then divide by 3 times 2 square and minus 2. That's 16. And you can see this will be 4. 2 times 2 is 4 times 3 is 12 minus 2 is 14. And you can reduce it this by dividing by 2, numerator, denominator, by 8 by 7. So this will be 8 by 7. And likewise, you figure out the rest of them. If you want to confirm this, uh, you can also put on on the calculator. Let me show how it is to be done. Is uh, okay. So I'll take a new page and go directly to calculator, and you know how it is. You just click Control and this. Sorry, you can put AN. So I'll put A and instead of equals, put control this, and then I think it was a fraction. It was 8n and divide by, I think it was 2n to the power 2 minus 2. You just enter and then you plug in a of, let's see if it is 2, just enter, you get the answer. See, we get, if it is a of 5, and you get like this. So that's how you do those problems. So it by default it gets reduced. So you can get, this is what you're supposed to do manually, and then also you can plug this in here also. So let me go to the next question. Question 3, you don't, there's only one question is asked. They gave you the n term and you're supposed to find out what is A11. So all you do is put a A11 equals 8 times 11, and then it is 4 times 11 square minus 5. So, and you know the answer, right? 4 times 11 times 11 is 121, and then it becomes 80 divided by 4 times 1 is 4. And this will be 470, I think 79. And I don't think anything crosses, you can keep it as it is, and you're done. So that's all it is. Let's move to question number 4. So question number 5. If you see the sequence, they gave you a and something is given to you. This is 4, I'm sorry. So this is 4. So an is given, and there's also an minus 1. Now what this basically means is, if the terms of the sequence are like the same, is 1, 2, and 3, and 4, and 5. So recursive formula means if you know the first one, and then suppose this is A1, so A1 is 5, and recursive formula says an any term is you add 4 to the previous one. So it is a n minus 1 plus 5. So it means any term any term is the previous term plus the first term, whichever that is 5. So the recursive formula says, so is if a1, the first one is 5, and any term, the next one is always 1 before plus 5. This is the understanding of recursive formula for the arithmetic sequence of, or sorry, for anything. In this example, it's going to be arithmetic sequence. So here it is this way. So I'm going to expand this to show exactly what's happening here. So an here is, now remember this, so this number this number is a2, the second one is a1 plus 5. Then this one, the third position is a3 is, which is a2 plus 5. If it is fourth position, so a of 4 is a of 3 plus 5. If it is a fifth position, a of 5 is the previous one is the fourth plus 5. So the 5 is the main important number. And another thing is you also have to write it. This thing is n greater than equal to 1 because, sorry, great 2, because the 1 is already taken care. A1 is 5, and this is greater than equal to 2. So hope that helps little kind of a conceptual understanding where this came from. So you can always see if this is 3, this is always 2. If this is 4, this is always 3. If this is 5, this is 1 less. And that's why you can see that an is the n minus 1, 1 less than the previous. So hopefully I'm making sense to you, and I go directly to check the problem. Okay, so this was given. I'm going to rewrite this, use the distributive property here as a. So this is an is 2an minus 1 and then plus 2 times 3, which is 6. Now here, so when you multiply 2 and 3, this 2 and 3 will make it 6. So in this case, the recursive formula says is the beginning one is given, a1 is 5. So if I draw like this, the table here, so a1 is 5. And then the second position number, A2, is all you do is double the previous. So this means you double the previous. So you double this previous. So it is 2 times the 5 and then add 6, which is 10 plus 16. So this answer is 16. Then the third position is you double the 16, that is A3 is 2 times 16 and plus 5. So that will be. So that's the mean. That's how you're supposed to find the answers for each one of them, like how I'm showing right now. I hope I know you can do the rest by yourself. But remember, this is not going to be arithmetic sequence because this is going to be 32 plus 15, 47. So this is 47. And look at the numbers. This number 5 and this is 16, and you don't see the same number every time. You don't add every time the same thing, but you double the first, and you add. I think I made a mistake. What did I do? 2 times 5 plus 6, correct. I think I messed up in this case. Let me correct it. So the first one is 4. So the A1 is 4, and A2 is, you double this. So it is 2 2 times the 4 and then plus 6. So this is 14. And again you double the 14, A3. You double this and then 28 plus 6, which is 34. So this is 34. You can see they are not arithmetic sequence. It's just a sequence, but not an arithmetic sequence. So I hope you'll complete your problem that is given. So that completes problem number 4. Question number 5. A, se- a sequence is defined. Okay, so this is what's the difference between the previous one? Here it says now you have to understand what is the meaning of this. Uh, so they gave us the first two terms are given. It means if I try to draw this, the first one and the second one are given to you. This is 5 and this is 2. So this is A1 and this is the second term. So they gave you the first two terms. And then the third one, and how do you create the third one is A3. All you do is A3 is you're adding the previous A2 plus A1, the previous one. That means you're adding the 2, A2 is 2, this is 2, and then A1 is 5, so this is 7. So this becomes 7. If you want to find the fourth one, so A4, you're going to add A3 plus A2, the previous two terms. That means you're going to add 2 and 7. So that is 7 plus 2, which is 9. So this becomes 9. You want to figure out the fifth one, you're going to add and put it here, right here. It means A5 will be A4 plus A3, that is 9 plus 7, which is 16. And that's how you do it. So I hope you understood this. So this is called, if you know the previous two, you can find the next one. This sequence also is called Fibonacci sequence. So the mathematician Fibonacci created this kind of a rule, and knowing the first two terms, you can get the next one. In this question, if you say find the nth term, so you're supposed to find the nth term. This is the sixth example of and several terms are given. You see the terms are given as so 4 terms are given 5, 10, 15, 20, and likewise you want to find the nth term, okay, the nth position. So this is 1, this is n, and this is a n. So the first, oh, sorry, this is the first. Okay. So all we are supposed to do is find the nth term. How do we find the nth term? Remember the formula is the nth term is always, you can write, you can see there's a common difference each time you're adding 5. So that's the D part which I'm talking about. So you always do the first term A naught or A1, sorry, A1 is the first term plus N minus B or D times N minus 1. So it's like D, the common difference is multiplied to N minus 1. So this will be 5 first term, and the common difference also is 5, and use the distributive property and just get 5 and then you're done. Okay, so I hope this is taken care. Let me go to the next question, problem number 7. So this is the n term. So here you write a n is 5 and then you're done. That's all it is. Now let's move to the next question. So question number 7 says, so you have given some terms that so you're supposed to find the nth term. I want you to think over it if you can do it by yourself. You see the pattern there. 5 is up, 6 is down, then the 6 and 7, and then the 7 and the 8, and the 8, and then there is a 9. That means I want you to focus on this 5 first. So from 5, so now this goes to 6, then goes to 7. So this adds 1. Each time you add 1, right? So that the top part is like a sequence 5, 6, 7, 8, where the first one is that's A1. So the formula is AN is A1, the first one, plus D times common difference, which is 1. So you can say this is D every time. And then times n minus 1. So here, the first term is 5, so this is 5, plus, and every time you're adding 1, so the d is 1, so 1 n minus 1. So this becomes 5 plus n minus 1, and you can see it becomes equal to n minus plus 4. See this part? So when you take away 1 from 5, you get n plus 4. So the top, so this one, the top numerator that works out to be the nth term for the numerator n plus 4. And you can see the bottom part, if you see, is add 1 to it. If whatever the top is, you add 1 to it. So that means this will be the numerator plus 1. So the final answer becomes n plus 4 over n plus 5. And you're done. So that's all the n term is. So in this box, the an is n plus 4 upon n divided by n plus 5. So question number 6 is asking us find the sum. Now what is the sum is? So first what is the meaning of, let's see you have the term of the sequence is A1, A2, A3, A4. These are the terms of the sequence. And what is the meaning of S1? It means it's the first one. What is the meaning of S2? It's called partial sums of the sequence. So it is the first one plus the second. What is S3 is the first one plus the second one, then the third one. And then we use the summation sign. And you did do this in algebra 2 and the pre-calculus. This means you're adding the first 4 terms. Okay, so that means we can use the summation sign and write this as, so summation SC, you can see there's this part, it means you write it like this shape, and then this basically means you are adding. Now what are you adding? You are adding the first from 5 to 9 terms you're adding. It means you're using the k equals, k means a variable, or so you're adding terms from fifth term until 9. So that's what this means. So, but suppose I want to write only this much. Suppose I write only S4, then I would write here, this will be This will be 1, 2, 4. If I want to write this will be the summation. K is 1, 2, 3. But what? The n. If there was an n term here, n, so whatever that, ak, so I have to write ak here. So this will be ak here. If I want to write this means it is k is ak. So AK is, of course, you can say N or AK means the same K term. So let's see, go back to the problem. So what this says here is, it says there's what are you adding is they just give you directly the K. That means you're adding K equals 5 onwards. So this K which you see here, it has to be, the first is it has to be 5, and then it has to be 6, then it has to be 7, 8, and plus 9. And you add all this number and you get the answer. That's all it is asking you. Now the same problem, suppose was asked k equals 1 to 5, and the k was something like this, then what would you say is this is 1 plus 2 plus 3 plus 4 plus 5. And what if it was k equals 1 to 3 and it was k square? All you do is you say, okay, the first you put k equals 1, so 1 square, 2 square, and 3 square. That's all that means. Let me take one other one. Maybe suppose it was 2k plus 1 and it was k equals 1 to 4. All this means this is 2 times 1 plus 1 plus 2 times 2 plus 1 plus 2 times 3 plus 1 plus 2 times 4 plus 1. That's it. That's all it's asking. But sometimes they can, so this one, it doesn't say directly from 1, but it starts from, so basically this is like saying k equals 5 to 9 of some maybe k, but that ak right now is k. That's how it is a little confusing. So the k term, the n term is 5. Sorry, the k. It's just a number itself. So don't have to. I mean, don't get confused. So it could be just AK also, and AK is given to 5 like this. So let me go directly and see how do we do with the help of calculator also. If you see, if I go to this calculator and use new one, take the calculator, and then you can see click on it, and there will be summation sign right here. So this is part, and you just put the k equals, put k, and then I want, it says from 4 to maybe 9, whatever that is. And here they give you directly k, and you enter, you get the total. So this part is so easy. Or I could just take this and put, instead of k, I can put 2k minus 5 like this. And maybe from 1 to 10. And then you get the answer, see, 60. So it's pretty easy. It's like adding the first 10 terms, or we can begin from maybe 4 and end with 15 here. The sum of the term from 4th term to 15 terms. You can just get total. Okay, so the difficult ones are the ones where you're going to use the formula like this and get the answer. Let me go do another one. So in this case, it says k has to be, what does this basically mean? So k takes the value 3, 4, and 5. That's all that means. So it means you have to do 1 over the 3 plus 1 over the 4 plus 1 over the 5. Now you have to use the least common multiple. That means 3, 4, 5. The lowest common multiple for 3, 4, 5, I can think is 60. So that means I have to multiply 20, 20 here. I'll have to multiply 15, 15 here. And you know the reason why I'm multiplying this to 12, 12 like this. I think 30, yeah, that's it. So this becomes 20 over 60 plus 15 over 60 plus 12 over 60. So you can add this together, 20, 35, and 47 over 60. Or you can put on the calculator, let's put it, uh, let me get this k to 3 to 5, so take that off. And this was 1 over k, right? So I put 1 divided by, so go here, 1 divided by 5, and I think, did I make a mistake? Let me check. I forgot to put a k there. I think I have to go, this I have to retype and put this as k, and now I enter to get this 47 upon 60. So this is how it works. So let's move to another. So this one is telling us to add k. Now instead of using k, they use it I. Sometimes they use r. These are the regular ones or n. So these are the 4 common variable you use. So this means, look at this n term is given to I 2 times I. What it means is you put you put I equals 1, 2, 3, and 4. When I put 1, this will become 1 times 2 raised to 1 plus 2 times 2 raised to 2 plus 3 times 2 raised to 3 plus 4 times 2 raised to 4. Like that's how you do it. And this will be 2, this will be 8. You can check. This will be 8 times 3 is 24. This will be 16 and this one is 64. You add all this, you get the answer. Or you can check with the calculator also. I'll go back this screen. Or suppose if you have forgotten, now how do we do? Go right here, click this one twice, and put I. This time it is I. So and 1 to 4, 4, and then I times 2 raised to the power I, and enter. You get the answer. Unless I made a mistake somewhere. Yeah, there you go. You got the answer. So let's move to the last one, I think. Yeah. Look at this question number 9. Wait. Question number 11. Write the sum of this, right? Now this time they gave you the terms 2 plus 4 plus 6 and until 54. So that's like the nth term. Let's say we don't know what position is, so I call it like an, and this is like a1, and you can see every time you're adding a plus 2, the difference, the d is the difference. Now I know it is quite obvious, like it is 2 plus 4 plus even number. So obviously, if the term is 54, so you'll take half of 54 because you can see these are all odd numbers, sorry, even numbers. So half of this becomes 27. But I don't want you to do this because not always is going to be so easy numbers. You could have got some 3 plus 4 plus 7 plus and then one number maybe 81. I don't know. So we don't. This will not be easy that way. So you have to do some little work. So what is that work is you have to use the n term formula, and because they gave you the last number, and I'll put it like a n is the very first term plus the common difference and then n minus 1. So that means that this is 54 and the first term is 2. The difference is also 2. And now we have to figure out what is that n. At what position? What position is this? So to know what position, we'll put n here. And then solve for n. So you subtract 2. If you subtract 2, you get 52. You get 20. And I use the calculator. So your n is 27. So all we are supposed to do is when we put the summation, we want to know that we need to put here from what number to what number. So 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 this answer here is the first term is 2 plus the 2 and then n minus 1. I'll write this. This is all you're supposed to put in the equation in the summation sign here 2. But instead of n, you can put n equals n. Keep it as it is and write down n is 1 to 27. Okay, so let's go directly to that. Let's see if I can put this. Okay, now I'll go directly to. Okay, so let me start with this. So this one, and here I put n, as I say, it could be n or anything, 1 to 27, because we have seen you are adding 27, total 27 terms, and here it was 2 plus 2 times n minus 1. Okay, and you enter, get the answer. So simple. That's all you're supposed to do. Now you may say, why not I? Can I put I here? Yeah, you could put I also. You could put I, and then you'll have to change this to I, and you'll get the same answer. Or you could put K also. Oh, but the main thing is you're supposed to know how do you. So this is the end term because you already know the first term and the every time the common difference, every time you're adding the same thing, so the first term and you're adding the common difference, these two. So in this example, as I said, it was easier to identify, hey, there are 27 terms, but then you have to get this nth term also. The very important thing is this nth term, which is an. Again, I repeat, this is an is 2 plus 2. You can keep this, of course, when you open it up, you get 2n minus 2, which is 2n. Just for so I'm almost done, and then last problem. This is a question number 12 is simply asking you how many terms are so this one says I is 1, 2, and what? So by just looking at that, how many terms are there? The top numerator is always 1, 1, 1, and there's also 5. Everywhere there's 5, so it has to be. So this equation, what equation is this? First of all, there are terms 1, then there is a 2, then these are like increasing by 1. So it is 1 to 8 here. That's one thing. And then this box will be 1 over 5 times n. That's it. Or because they give you I there, you'll write I. And that's all you're supposed to write there. That this is that AI, or you write AK is 1 over 5K, or you write AN is 1 over 5N. And that's all it is. And with this, we complete 13.1. Hope you complete it, and I'll try to make the next video 13.2 also when I get time.